problem number 8. Remember that the reference angle is the acute angle between the terminal side of an angle and the x-axis. Part A says we want to find an angle whose terminal side is in quadrant 3 and whose reference angle is 30 degrees. In part B, we want to draw that angle. I think I can do both at the same time. Let's see. If my terminal side is in quadrant 3, then I'm going to have to rotate around a little while. How will I know when to stop? Well, I want the reference angle to be 30 degrees. Reference angle is the angle between the terminal side and the x-axis. In other words, here's the reference angle right here. So I need to go 30 degrees past the 180 mark. Here then is a picture of angle alpha. Angle alpha is this blue angle, the angle that starts at our normal starting spot, the positive x-axis, and rotates around to that third quadrant terminal side. Well, what's the measure of angle alpha? Well, obviously it's just 30 degrees past 180. It would be 210 degrees. However, I'm being asked to give the answer here in radians. Now, hopefully by now you have that memorized. 210 is the same as 7 pi over 6. If you needed to think it through, you could think, well, 180 is pi, 30 degrees more is another pi over 6. That's 6 pi over 6 plus 1 pi over 6 is 7 pi over 6. Part C says, well, let's use the reference angle definition to calculate sine alpha. In order to do that, I have to find some point along the terminal side. Again, typically what we do is we drop a perpendicular to the x-axis, forming a little right triangle. And in this case, the triangle I've formed is a 30, 60, 90 right triangle. Well, that's great because I have a standard labeling. The easiest labeling is the side opposite the 30 gets a 1, the side opposite the 60 degrees gets a root 3, and the hypotenuse gets a 2. Now, I'm not in the first quadrant, so I do need to think about positives and negatives. The r is always positive. I can see here that this is a distance to the left, so it's a negative, and down, so this is also a negative. With this labeling, I can easily calculate any of the 6 trig ratios. The sine ratio for my angle would be the opposite. Again, I'm looking at this reference angle now. It would be the opposite leg, which is -1, divided by the hypotenuse, which is 2. -1 over 2. Or you could think of it as the y, the -1, divided by the r, the 2. Part D says, what's the relationship between the answer we just got and sine of 30 degrees? Well, if I was to calculate sine of 30 degrees, I would be here in the first quadrant. The picture would be exactly the same, I just wouldn't have any negatives. And so sine of 30 degrees would come out to be positive 1/2, opposite over hypotenuse. The answer to the question then is sine alpha is equal to the negative of sine 30 degrees. They have the same value, they just have different SIGN signs. Another way you could answer the question is you could say they are opposites. One is simply the negative of the other. In problem 9, I'm being asked to draw an angle in standard position and then see where the terminal side intersects the unit circle. This is the unit circle, so I know the radius is 1, and all these spots, therefore, are exactly 1 unit away from the origin. My first angle is -3 pi over 2, so if I start at my usual spot, I'm rotating around clockwise. 3/2 is 1.5, so -1.5 pi. Let's see, here's half a pi, and then a whole pi, and then 1.5 pi takes me to right here. So here's my terminal side, and right here is the spot where the terminal side intersects the unit circle. That is, of course, the point 0, 1. Letter B, my angle is positive 10 pi. Well, when I rotate around 2 pi, I've gone all the way around once, and then 4 pi, 6 pi, 8 pi, 10 pi, a little bit hard to draw, but the point is I'm just going to end up where I started. The terminal side will match the initial side. Here is the intersection point. That is the point 1, 0. And then the last example, again starting here, 7/2 is 3½ as a mixed number, so I need to go 3½ pi in a counterclockwise direction. Well, one rotation takes me to 2 pi. Here would be 2½, and then 3, and then 3½ would take me to right here. Here's the terminal side. Here's the point we're looking for. That is the point 0, -1. And then number 10 is interesting. I've been given a point here in the second quadrant. I've been told the distance from the origin to that point is 12, so there's my R. And I've been given the reference angle here is 26 degrees. I want to find the coordinates of the point. Now I can visualize that by dropping the perpendicular. If I can figure out this distance here and this distance here, then I'll know the coordinates of my point. Well, I can use trig to do this. For example, let me call this side here y. I can set up a little trig ratio for this triangle. In particular, the sine of 26 degrees is equal to the opposite over the hypotenuse, y over 12. If I just multiply both sides here by 12, I have solved for y. I get y equals 12 times sine 26 degrees. I can type that into the calculator and I'll have that distance. Let's see, I'm in degree mode. 12 sine 26 gives me about 5.26. So my y is about 5.26. How about this distance here? Well, I just need to pick a different trig ratio. Now I'm going to link up the adjacent leg in that right triangle with the hypotenuse. That would be the cosine function. So I'll say cosine 26 degrees is equal to adjacent over hypotenuse. Once again, multiply both sides by 12. You've got that x by itself. I'll go to the calculator. 12 cosine 26 degrees is about 10.79. Now, here's the only tricky part. I'm not in the first quadrant in this picture. This angle that's drawn there in the second quadrant is not actually 26 degrees. Here's the actual angle. 26 degrees is the reference angle. I've done my calculations pretending that my angle was 26 degrees, and that's fine. I just have to remember when I go back to my picture that clearly x in this picture is a negative value. It's going to the left. So when I write down my final coordinates of this point, it's not going to be positive 10.79. It'll be negative 10.79. The y is positive. In the second quadrant, the y has a positive value, so I can go ahead and use the 5.26. So here would be the final answer. Just be careful when you're not in the first quadrant. You have to think about the positives and negatives. Again, this happened in our calculations because we used the reference angle instead of the actual second quadrant angle.